start, Shailesh.
Welcome you all to this webinar series on data engineering from AFour Technologies. I'm your host, Shailesh Gaikwad, for today's session. I have over 17 years of software engineering and data engineering experience, worked on multiple BI and analytics solutions using Azure Cloud and AWS. Currently, I work as a technical project manager with AFour Technologies. I wanted to share with you the official uh, listing of what services we provide in data engineering. So at this particular site, you can find out what we as a group provide services when it comes to data engineering. In this web series, our data engineering experts will deliver sessions on introduction of data engineering and how to architect large scale systems from data engineering perspective. So let's start with today's session, data engineering. Day one. So we have divided this webinars into multiple sessions wherein each day we will be introducing you to some concepts regarding data engineering. So today is our day one and we will be introducing you to data engineering concepts. Now, before we start with data engineering, I just wanted to make sure that we all understand the world of data. When it comes to data, I want to take one simple example through which you can connect with what I want to say. What do you mean by data? So let's take one example. For example, during World War II, Allied forces or Royal Air Force Army was raiding German cities with their bomber planes. One observations when this raids happened, the officers of Royal Air Force Army observed that many planes were getting shot down by Germans. And they had a meeting and they asked their product engineering team to how can we go and reduce this number of planes which are getting shot down. Now, the question was there how to reduce this uh, casualties or how we can reduce the number of planes getting shot down. The simple answer one person gave was why don't we go and just add some protective layers to these bomber planes? Why can't we just go and armor these bomber planes? Now the next question was, do we really need to go and armor that entire plane? And if we do so, how come we will ensure that that plane will fly for a longer duration with loads of bombs? So they asked another expert to do something about this problem. Now the expert asked his team to just go and make sure that they are noting down where the bullets are hitting those bomber planes and come up with some kind of report so that he can just go analyze and give solutions in order to make sure that we are giving some kind of protection to our bomber planes. So the team which was extracting that data, right, when the plane used to come back to the base, they used to just mark that bullet locations on a particular map of that particular plane, and they entirely they got this kind of image, and they went back to their experts and they asked, now tell us where we should go and armor these planes. Looking at this bullet hits, the expert, without even thinking, he just gave them a solution that just go and add protective layers to wherever those bullets are hitting that bomber planes, and let me know the results. So this was the first iteration wherein they added protective layers and they again started to monitor those or monitor or observe those planes. And but the number of uh, planes getting shot down didn't reduce. So they came back to their expert and they told that this is not working. And then the real data analysis kind of thing happened. He looked at that data again, the images where the bullets were hitting that bomber planes, and he came up with the final solution that if a plane is coming back or returning back with this number of hits, that means the planes which are getting shot down are are the planes which are actually getting hits on their vulnerable parts. So he gave the final solution: go and add protective layers to the bomber planes at this circled areas, and things improved. Now, what we learned out of this exercise, we learned that there, at any given point of time, when it comes to big enterprises, they are struggling with some kind of problems. In order to learn those problems, one needs to understand what is the business use case. In order to learn more, someone has to acquire that data, prepare data in such a fashion that they can analyze what is happening over there. You might need to come up with some models, you need to deploy, you need to iterate through the results to make sure that you are hitting at the right point. So you here, as you can see, that we understood the business case, we acquired and prepared data for the product engineering team to add new features or new enhancements, and then they came up with some kind of models and they deployed. Some iterations happened until the customer signed off. So this is something which we learned out of that exercise. And when it comes to data engineering, we know that what steps one needs to follow in order to make sure that they are solving real time scenario. Now, when it comes to data, you also need to understand what is data and what kind of data we are dealing with. In modern era, we are getting tons and tons of, of data across the world. Millions of devices are generating data every day, every second, every microsecond. And when it comes to this data, we know that there is one term called big data, and it has three V's. These three V's are nothing but volume, velocity, and variety. When it comes to volume, we are talking about data which is in terabytes, petabytes, generated through different transactions. Then velocity. As I already told you, that this data is getting generated at a very rapid pace, and for that we have different terms here again. Some is coming in batches, some is near time, real time, and some is continuous, which is again a streaming kind of things. For example, when you take area or example like IoT, where sensors are generating data continuously. Now, data could be of different varieties. It could be structured, semi-structured, and unstructured. Structured means the data is following some kind of model wherein you have columns, defined data types for that particular data, and you can easily infer something out of that data. When it comes to semi-structured, it could be a JSON format or XML format. Unstructured is a data which is like your images, audio files, video files, which again can help you in order to create some real-time scenarios or real-time applications using using unstructured type of data. Now we have already seen three V's of big data. Now let's move to the next slide. When it comes to data science life cycle, we have already seen some steps, right? When they wanted to solve the bomber plane uh, puzzle, they actually try to acquire some kind of data so that they can prepare and then they can give some solution for that. So when it comes to modern uh, data projects or data science life cycle, this is the life cycle uh, when it comes to um, the big picture. You start with some business understanding. You acquire data and you understand data, and then while acquiring data and understanding that data, you need to understand what all data sources we are dealing with, whether we are dealing with on-premise or cloud, whether we are dealing with databases or flat files. When it comes to pipeline, is it a streaming thing or a batch which runs at particular time in a day, or whether it is running with low frequency or high frequency. You need to also understand what kind of environment we are targeting, whether it is on premise, that means all this particular thing is set up in entirely in on premise with infrastructure of that company, or we are taking help of cloud. It could be Azure or AWS. Again, databases versus data lake, whether we are dealing with small, medium, or big data. When it comes to big data, we are also dealing with preparing that data. We need to clean so that we can use that data in order to infer or get into insights of that particular data by applying some analytic tools on top of it, or adding some visualizations so that business team can learn something out of it and they can take some corrective actions. Now, when it comes to data engineering, we are going to deal only with this part. But yes, when it comes to data science, there are other teams also involved, which actually gets access to this data. They create some kind of predictive models. They apply those models, and then again they iterate in order to make sure that they are solving some problems or scenarios for the business. Now, we have seen how data engineering block fits into data science lifecycle. But when it comes to data engineering, this is all we should know. This is all about data engineering. That it develops. It is all about develop, construct, and maintain large scale data processing systems that collects data from variety of structured and unstructured data sources, stores that data in scale out data lake, and then you prepare the data using ELT techniques for the data science, data explorations, and analytic modeling. Now, why we are saying ELT? Because the traditional way of working with data is ETL jobs, which is extract, trans, transform, and load. But when you dealing with the big data, you cannot transform that data on the fly. You need to first load that data and then apply transformations. That's why here we are referring to ELT techniques. Do you have any questions for me up to for the slides which we have covered?
What is the meaning of ELT? This is Vinay here.
What is the
ELT technique.
Yeah, ELT is extract, load, and transform. So basically, you extract data, you load that data first to your data lake, and then you run your transformation techniques.
It's
So
like to
earlier,
ATL.
uh, earlier we used to know only one thing, that is ETL thing, right?
Yeah.
T comes in between. But when it comes to big data or dealing with the very large scale data, you
Hmm.
cannot transform data as and when it comes. You need to first load that particular thing and then you need to apply transformation techniques. So that's why here we are referring to ELT. So it depends on the scenario, you will have to use ETL or ELT techniques.
Any specific tool for ELT technique? Yes, keyword only.
There is no specific tool. Only thing is that when you're constructing or architecting your pipelines, you need to take care of that thing. So, for example, when you're architecting your pipeline, you need to first uh, ingest your data into data lake, and then load that data, and then you apply some uh, uh, transformation jobs in order to prepare that data.
Okay. Okay.
Okay. So let's move to the next slide. When it comes to data engineering, we have four blocks wherein you need to understand what data sources we are dealing with, what kind of pipelines we are dealing with, what is the environment, and where we are doing our uh, data wrangling, exploration, and cleaning. So when it comes to data source, as we have already checked that we have on-premise and cloud. Uh, our database can be on-premise, and then files which are getting stored on data lake. Then pipelines again, if whether we are dealing with streaming or batch pipelines which runs at a particular frequency in a day. For example, you daily you want to extract number of users to whom you want to send promotional emails based on some criteria. So you can say that this kind of jobs are running daily. And then streaming is something, for example, your area like IoT, wherein you are getting in streams continuously, and you based on that you'll have to take some kind of actions. And then again, your pipelines could be low frequency. I mean, run once in a week, or high. It could be run every hour, and that kind of frequency of the pipelines. Then environment again, on-premise and or cloud, uh, wherein if you're targeting environments like you have infrastructure, some infrastructure already there, which you don't want to take into cloud. So you are dealing with hybrid kind of things, wherein something is there in on-premise and something is there in cloud. Again, when it comes to data, it could be small, medium, and big data. So we will have a detailed section about this thing in coming sessions. And then last point is that we need, whenever we are dealing with data, first thing first is that we need to make sure that we are validating that data, we are uh, dealing with missing data, then we are cleaning up that data so that our visualization and analytic jobs can run on top of that. Now, when it comes to data engineering, we saw that how it fits into data lifecycle and data science lifecycle. And based on that, we know that there are different kind of roles involved in that lifecycle. So when it comes to data engineering, we know that for data engineering, we need to have roles like data engineer, who is responsible for creating data pipelines for big data platforms, and he's responsible for data integrations in databases, data warehouses, and data lakes. He also works with various cloud and on-premise technologies. The core skills which are required when it comes to data engineer is he should know how to deal with data and web service integrations. He should have good knowledge of databases, data warehouses, and Hadoop ecosystem. And for running analytics jobs, he should know how to run jobs or how to write jobs for Spark or similar kind of tools. The common programming languages one should know when it comes to data engineering is Python, Scala, Java, and SQL. The next role when it comes to this life cycle is BI developers. So BI developers are the ones who are actually creating some kind of visualization to show what happened in past. So they don't care about what is going to happen in future, but they are going to share you the insights what happened in past. So a BI developer is nothing but one who documents business needs on data analytics, develops BI systems, reports, and dashboards to support them. Also, he works to integrate data into BI systems. So when it comes to BI developer, one should know how to model that data, how to run ETL jobs, how to visualize that data using some tools like Power BI or Google Data Studio. And then data analyst. Data analyst is the one who actually uh, also gives you insights into what will happen in future. So he is the one who extracts data from business systems, then he analyzes it, creates reports and dashboards to highlight trends and other business information for end users. So when it comes to skills for data analyst, one should be good at analytics, and then he should know how to report that, and he should be good at data visualization. Now, this is the new job role which is coming up in near time is AI engineer, who actually works with cognitive services like speech analysis, text analysis, and then he works with. So basically, he is the one who actually embeds program into some devices, and then those devices does some work for you. For example, uh, Alexa, right? I mean, you order your Alexa, and Alexa understands that statement, and it runs whatever you have asked for on a Fire Stick, or if you want to play a song, you just order it.
Shailesh, there is a question from outside.
Okay.
Can there in the chat?
So yes. So what kind of transformation technique we have? So when it comes to transformations, when you're dealing with data, right? Data is generated by your devices. That could be a normal telemetry, it could be client telemetry or server telemetry or server logs. Now you cannot directly go and add some visualizations, or you cannot run some analytics job on top of raw logs. You need to clean that raw log. You need to get rid of some logging which is not required for your business case. For example, IS server logs, wherein you are actually in those logs, you are actually storing what kind of user is hitting from which IPs, and then what features he is using, and then whether that particular request was served. I mean, HTTP response codes and all that thing. For example, for a business use case, you just want to understand whether in that particular app or a web software or portal, you want to just understand which features are getting hit, or what are the popular features, right? So you might not be interested in the what from which IPs that request is generating. So you are actually interested in what APIs are getting hit, and for which APIs there is a 200, that means HTTP okay was, I mean, which API was successfully served, and which was uh, uh, hitting some kind of exception. So you are interested in that. So based on your use case, you apply different transformation techniques. So it could be so pure SQL, or using some Python. You are cleaning that data, and then you are running some jobs in order to get the insights, like, okay, in this particular website, only my people are just browsing my catalog, they are not. And then you will see that people are not ordering. So you want to understand why people are not ordering. Then you can target only those APIs, and you can learn that, okay, when people are trying to order, something is going wrong, some exceptions are getting generated. So you will ask your development team to focus on that, and they will fix. And again, you run your analytics jobs on whatever time frame you want, and then you will see what is the improvement. So transformations are unique to that particular business use case. But yes, you your you as a person who wants to solve a particular problem, you will ask your data engineer or your team to go and apply this kind of transformation so that you have data with only that kind of fields on which you want to run your jobs or analytic jobs, or you want to apply, or you want to connect that data to your visualization tools. uh, is that what is that answers your problem, I mean your question?
Shailesh, you may not get the feedback immediately. We can
Okay.
continue after answering.
Okay. No, so this is all about AI thing, and then last but not the least is the one who actually is getting more importance these days is a data scientist. He's the one who actually is solving some kind of uh, use cases wherein you want to penetrate more. You want to understand what can be done in order to make sure your penetration is more. How you can solve marketing problems and all those scenarios. So he's the one who gathers and analyzes data from databases and other source systems, source system running machine learning algorithms and predictive models. He creates visualization for business users. So the core skills required for any data scientist is he should be good at statistics and then machine learning. Programming languages he should know is Python, R, Scala, or SQL. So he's the one who actually models. He deploys those model, and based on the observation, he accurate for solving that particular business problem. For example, take a simple example could be when it comes to operations team, right? Operations team who is getting number of tickets like on in particular corporate network that when he installs some kind of applications, then number of crashes happening is has increased, right? So he logs into the ops portal and he creates tickets. So a data scientist can uh, do some kind of apply some models in order to make sure that he's actually letting know ops team that beforehand that okay, for this particular software with this particular hardware you might see number of tickets uh, uh, going up. So he's classifying the hardware so that operation team is now equipped with dealing with such kind of tickets. So this is simplest example I took, but this can go up to any other level. Now let's deep dive into what role or what core skills a data engineer should know when it comes to data engineering. So we are dealing with data engineering here. So I just wanted to make sure that when it comes to this role, what programming languages one should know. He's the person who should be able to write jobs. So he should be good at either Java, Scala, or Python. So jobs are nothing but he's writing some kind of transformations over there. He's actually cleaning that data. He's making sure that whatever data he is getting, he is applying right data type for that particular data. So if there is a date timestamp which is coming in string, and for your analytics jobs to run, you want that thing into a proper date time format, then he's the one who actually working on data data lake store. So what do you mean by collect and ingest? For example, in any enterprise, there are 100 servers which are taking care of some applications, right? And there are some now, and also that company is also using cloud technologies to deploy their applications. Now here we want to create some insights based on the on-premise applications which are running and cloud. So he's the one who's collecting data from on-premise and bringing that data into some data lake, and also pulling logs from cloud wherever those applications are uh, running, and it is getting that data into a common path in data lake. So he's writing some kind of pipelines wherein he's extracting those logs and getting that data into data lake. So he should be able to work with some of the tools like Azure Data Factory when it comes to Azure Cloud, or maybe for open source, he should be knowing some tools like Kafka, and Kafka, and then some services from AWS side. When it uh, Once he collects and ingests that data into data lake, we need to manage those that data. So or we have to run some transformations and put that data into some other uh, storage, for example data warehouse, uh, wherein we are actually aggregating that raw logs into some kind of format wherein you can directly run analytics jobs, or you can connect that thing to your visualization tools. And for running analytics jobs, one should know what is Hadoop ecosystem, and how to run jobs in Spark. So Spark helps you to run your queries or whatever jobs you're writing in much quicker and performant way. So these days, using Spark, there are various tools and technologies available. For example, when it comes to Azure side, we have Databricks. Databricks is also available in AWS. AWS also gives you an option of to run your jobs using Elastic MapReduce, which again takes help of Spark in order to run jobs on big data, which is lying out there on their uh, S3 buckets or some other locations similar to that. So this is all about data engineer, because he's the one who is actually the backbone data, and storing that data and processing that data so that other teams can consume. So in short, he's the one who is in charge of managing data workflows, pipelines, and ETL processes. So this is a simple pipeline. Whatever we mentioned, right? Whatever we discuss, this is all about. One should know when it comes to working with big data and processing big data in order to get insights or run some kind of analytics jobs to get deeper insights into that particular use case. So you get, these are the sources from where you are actually getting raw logs, and you're ingesting that data into your storage. When it comes to storage, I'm talking about some kind of data lake. So this could be on premise, it could be cloud, or some other sources which are um, giving access to their data. For example, uh, data could be web source also, wherein, for example, you want to analyze you are selling a product in multiple geolocations, and you want to actually uh, in visualization, you want to just see how much sales happened in USD. So there could be a source wherein you are actually getting daily exchange rates, right? So you're also, so daily exchange rates means every day your exchange USD conversions are different, right? So there could be a web service which is giving you daily or hourly exchange rates, and you're getting that data, and then you are uh, creating some kind of process logs wherein you're actually uh, converting the local currency into USD, and then finally you can see visualization which is showing profit earned only in USD. So sources could be anything. You need to run some pipelines to get that data from different sources to data lake, and then run some prepare and train jobs to process that data and put that thing into data warehouse, and from wherein your end users can consume that data to give more details to your business users. Another uh, form of that cycle is same thing, only difference is here is Polybase. Polybase is nothing but a technology through which a language through which you can query different sources at one go. So in a particular SQL query itself, you can target your RDBMS and Hadoop, and you can write queries to uh, write queries to join those different data and create get output which can be used to store into your data warehouse thing. So with that, I would like to conclude today's session. If you have any queries, do share with me. Let me check. Is there any other? No, we don't have any other questions here. So with this slide, I would like to conclude, and we will take it forward in tomorrow's session. If you have any queries, do come up with those queries in tomorrow's session. We will address those queries first, and we'll move forward with the next session. Thank you to all of you for joining this session. If you have any other any message from me, just let me know.
Thank you, Shailesh.
Yeah.
Thank you. Thanks, Shailesh.
Thank you.
Shailesh, there is a question now. What is Polybase?
Yeah, so Polybase is a simple SQL kind of language wherein you are actually querying RDBMS as well as your Hadoop ecosystem or data lake files. So it's simple select star from some database when it comes to RDBMS, and when it comes to reading from data lake, you use select into some alias, and then you gives that path, and then path of that data lake store, and then you actually join that two data into one. For example, you want to join different census data with the location. So location mapping is already there in the RDBMS, but when the sensor is generating the data, it just have the IDs with that census data. So you want to know basically from which location. I mean, you want the mapping, right? So you can have this mapping in your RDBMS and the real data into your Hadoop ecosystem. It could be a data lake, and then you join that data in order to get some kind of table which you can store in your data warehouse. So it's a simple SQL, TSQL type of queries only. You don't have to uh, put you don't have to invest from your side to learn that particular thing. Only thing is that you need to just learn the syntax, small tweaks in that syntax to join data from Hadoop and SQL. I think I answered that thing. If any other question, do let me know. Maybe we can take it in tomorrow's session.
Okay.
Okay. Thank you.
Thank you, Shailesh.
Thanks, Shailesh.
See you tomorrow.
See you.